a minute start. Let me wait some seconds. The live event hasn't started, not yet. Done. Hello everyone, welcome to the first edition of the Business Application Latam Summit. Welcome to this event. It's a English, Portuguese, and Spanish event. We have many talks, and we have many speakers. I want to say thank you everyone to join us, and thanks Susana. Today we have a section introduction to DAX. Susana, go ahead. Thanks for joining us.
Okay, thank you for the introduction. Hello, everyone. I will start my presentation. I believe that you are seeing the first slide. So, hello. First of all, thanks for the opportunity to be here presenting this session on introduction to DAX at this conference. I know that some of you, when registered in the session, maybe you were expecting Pedro Reis to present, but he couldn't come, and I am here to replace the session. But don't worry, it will be the same content, the same thing that he was planning to present. Some of his material is this. So I hope you still enjoy the session. So thank you for the opportunity to be here to present you these concepts about DAX. So a bit about myself. I am Susana Sousa. I am a business intelligence developer for the past 3 years at Natixis, which is a bank part of the BPC group. I can say that I'm an enthusiastic with data and algorithms, aiming to improve the way the data is communicated. During this time, I've been working in multiple projects, especially migrations of reports from the traditional BI platforms to other BI tools, more recent, more focus on the Microsoft tools. So I have experience with data processing, data modeling, and also data visualization steps. I really think that the technical events like these are really important for all of us to learn a bit more about the tools that we work with, some more tips and tricks, see how the other people is working with the same tools. So every time I can, I try to attend them, and today I'm here in the other side presenting you some of my knowledge. So I really hope you enjoy and you can learn something today. Starting right from the beginning, what is DAX? Well, DAX stands for Data Analysis Expressions. It's one of the languages behind Power BI and Power Pivot and also Analysis Services Tabular, and it's the language that we use when we want to define calculations and queries. Why DAX can be important for me? Well, DAX can be very useful for different jobs. For instance, if you are a business user or an analyst, it will give you the power of controlling the business logic on your side. You can do more specific calculations regarding your needs. As you are the business expert, you will control the business logic without having to call the IT guy every time you need to add a new specific calculation or a new logic to your report. On the side of the IT guy, he will leave the logic for the ones that understand it better and focus the time in the developments of the model, applying the good practices of modeling, improving the performance, build the best general model that can then be used fully by the users. So both of these profiles will need to understand DAX in order to potentiate the specific tasks that they do. When we start to talk about DAX, and if you already search a bit or have the interest to start learning, you will see that there are always a set of concepts that appear. First, you will see something about creating measures, apply filters, iterators, the calculate, which is the most powerful function in the DAX stack. and also concepts of expanded tables, filter context, row context. Well, some of these concepts can be very difficult and very complex when we start digging into this. But as this is an introduction to DAX, is a session mostly for the beginners, I will try just to pass through the basic concepts and through the main things that you need to know if you are starting this journey on DAX. Let's start with the fundamentals. And I would like to start with this image. So if I ask, what is this? The normal answer would be, well, it is a table. And in fact, it is not a false answer. In fact, it seems like a table. It behaves a bit like a table, but the truth is, this is much more than a table. In terms of DAX, this is a visual representation under a table visual of an expression, total sales, that is evaluated in the context modified by filters. In this case, in the context modified by the state field. Well, this is one of the fundamental concepts that you need to have in mind. For me, it's one of the important things to know in the starting working with DAX, because it is really what it means. Total sales is a measure that is evaluated in a table visual for each different context that is applied. We can say that it is calculated at each cell level. So for each one of these cells, again, the result of the measure is filtered by the state. And this is applied for all these cells that we can see here, but the same concept is applied to the total cell. The total is also the result of the measure, in this case, when no state filter is applied. Well, when all the states are influencing the measure. This is a very important concept, the cell evaluation. And also, if you came from an Excel background, for instance, most of the time what we admit as the total is the sum of all the rows that we have above. But here the concept is a bit different. As I said, the total is also a cell that is evaluated in the context that is applied. And if you look at this simple example, you understand better what I wanted to say. You have here a simple measure, and here a measure absolute that is the absolute of the first one. And you can see that the totals are -7 when we are here considering the measure when no category is applied, and it corresponds to the sum of these. But when we are looking to the absolute, the total is the application of the measure, the absolute, when no other category is being applied. So the good value is 7. Okay? Just a simple example for you to have this concept in mind. For sure, in the future, when you start to creating your DAX formula, this small issue will appear and you will understand better what is going on. So let's keep on this concept of cells evaluated, expression evaluated at the cell level. So another example, we can see here a matrix with multiple cells, and each cell has a different value. So according to what I just said, each cell is the result of the application of multiple contexts. In this specific case, this is the result when the Colorado state is being applied when we are in the 2015 year and the employee is Berta Greer. The cell below, it has a different value because the state that is being applied is different. And these filters can come from the different places. They can come from the fields that we put on our visual, from the filters that we apply to the filter panel, and also from the other visuals if they are interacting with each other. In this case, if in this visual I select the male portion, all my data in the matrix will be also filtered by the gender male. So that's how it works in terms of sales evaluation. And the filters that we applied can come from different tables. As we see, we can filter on the employee, we can filter on geography, we can filter on a date, and all these filters will automatically propagate through the relationships according to the relationship direction that was defined inside the model. So now the question is, how does it work internally when the filters come from different tables? How DAX deal with that? Well, that's when we introduce the concept of expanded tables. What is that? If you drag fields from sales table, and then you drag fields from date, and then from employee, and then from geography, internally, what DAX is doing is a join between all the tables that you have fields selected. And these kind of joins are applied according to the relationships that you define in your model. So for the calculation of the measure that you want, for the evaluation of the measure, in the background, it computes this expanded table. And then you apply filters, right? So in this case, you apply the filter on here, you expanded the cells with date and filter the here. And then the total value that he wants is the result of these individual rows. Then if you keep applying filters on employee, it keeps expanded the table and filter the rows. Now we have a different a reduced number of rows, and so the total is different, is less. And if we keep filter on that, for example, on geography, we keep reducing the number of rows and the total is 64. So this is a very important concept for you to have in mind, for you to understand what is happening when you create your formulas, when you drag the fields from Power BI to a visual and apply a metric. This is how DAX is thinking behind. Two other very powerful concepts is row and filter context. As I said, these concepts can become very difficult at certain points. So the main thing that I would like you to give from this session is that the filter context is exactly what I explained so far, is a set of filters applied to the evaluation of a DAX expression, a measure, coming from different places. In the terms of row context, this is exactly what you have when you go to the data tab in Power BI and you see your table of data. Every row is different. Every row here has a different context, a different row context. And whenever you iterate a table using, for instance, an iterator function, you are using this concept of row context. Keep going, we have another concept that is very important to have in mind. The return types of DAX. DAX has simply two return types. It can return a table or it can return a scalar. And it's very important for you to understand which functions return each one of these types. So for the tables, we have the functions filter, all, generate, summarize, the top n that returns a table. And then you have functions like the sum, the count, the average, calculate, the SumX that returns a scalar. And it's very important for you to understand because very frequently when you start creating your DAX functions, very frequently you nest multiple functions. You inside a calculate, you use a sum, then you use a filter. And if you know the syntax of each formula and you know the returning types, you will better understand how you can nest all the functions. And the best place for you to learn about it is the DAX guide. This is a site in the internet where you have a list of all the available functions in DAX, and you can have information about which is the syntax, which are the returning values, examples on how to apply these functions, and also some remarks like if the function works with the old version of Power BI or just with recent versions, this kind of information that can be very useful. Okay. So now I will present you a few learning resources, but before, just a disclaimer. You will not learn DAX in this session, not even with my demo after. You will not learn DAX just in 40 minutes. And when you start to learn DAX, you will face probably, I face it, the Dunning-Kruger effect. What is that? At the beginning, you will learn the basic concepts. You will be able to perhaps do some simple metrics, use some calculate with a simple filter applies, and at a certain point you see, oh, it's not so difficult to use DAX. It seems very easy. It's when you are at this point. But then you will face a challenge and you will want to do some different measure that it seems easier for you, and you could do it in a very simple way, perhaps in other tool, but you can't find a way to do it in DAX. It seems very complicated. It's when you enter in the valley of despair. But my message for you here is don't give up. Keep practice, keep learning, and then you will get into the path of mastering DAX. And if you keep this journey and if you insist on yourself, you know you will succeed. And for that, there are multiple online resources that you can use. You can go to the SQLBI.com blog. You have the DAX guide, the DAX patterns, the books that are the Bibles of DAX. So a lot of resources on the internet that will help you on this journey. For me, I can say that SQLBI.com already saved me a lot in my use cases when I build my reports. Every time I have something a little bit more out of the box, they have the answer there, and very well explained, very well with a contextualized. So I think it's a really good resource. And to practice, you have always the Power BI desktop, also the DAX Studio tool, where it allows you also to analyze the performance of your queries and better understand each one of the steps that is being calculated. And since this here, there is another tool, which is DAX.2. This is a tool in the browser where you have a few data sets available and you can create your DAX formulas across these data sets. And it's very good for you to learn and to try and understand how to do some of the things that you want to do. And this tool is the one that I will use in my demo. So now it's demo time. The demo will be very simple, with the very basic concepts. So the main goal is to create with you some DAX queries, to show you how to manipulate some tables, and also present you the main functions, the functions that you will for sure use in your work. So let me just share the other screen, but before, drink a bit of water. Okay, hence I will show you the DAX2 tool. So this is the tool that I was talking about. You just need to type on your browser DAX2 and you'll be there in an empty screen. So very easy to access, it's in the browser. There are two data sets available, the Contoso and the DAX guide. And for each one of the data sets, you have some tables, and you can also take a look at the model that is behind for you to understand how it works. So in this case, for Contoso, it's a simple star schema model, sales in the middle, with some dimensions applied and the relationships already defined between them. So I have already here a script prepared for some of the things that I want to show you. In here, the main function that we will use is the evaluate. Every time a DAX query always started with an evaluate, which retrieves always a table. Okay, so for instance, I will use, as I said, the Contoso data sets that are these 5 tables, and I will start by evaluating the product table. And when I run this, I can see the results of my data. The complete result is too large, it has been truncated, but it's like a preview of the data that I have on my side. So with here, I can start manipulating a bit what I want to see. So imagine that I want to retrieve all the values of product brands. I will do an evaluate and I type the function values. You see that at the same time I'm writing, I have an autocomplete, which is very useful for you when you are coding, right? And also a small tip for each function, of which is the argument type that is expecting. So for now, values is expecting a table name or a column name. And I will say that I want a column. I want to inspect values of the column product brand. And here it is, 11 distinct values. If I could use another function here that in this case returns me exactly the same result, which is the distinct. And if I run, you see it's the same result. Another thing that it's also very interesting in this tool is that it gives you, remember the DAX guide site that I just told you that it's very useful. You have that incorporated to this tool for you to, when you are writing a function, you directly have access to the information of it. What is the function, which is the syntax, the argument type, the returning values, and even some links to other articles or examples. So it's a very powerful tool when you are learning. So let's keep going and trying to do other use cases. So imagine that you want the product brand column, but with all the values. In fact, without a distinct, like a select to this column. So you can do that by using the function select columns. And you see it asks me for a table. It comes from product table. It asks me a name, and it can be any name. I will put my brand, and then the column, which will be product brand. And when I evaluate this, I have the brand column exactly how I have it in the main table with all the duplicated. And we can also do, it's count the number of rows in this table in the product. So again, I always need to do an evaluate, and I use the count rows function that tells me, as we can see here, counts the number of rows. It's for count, like that. Count rows counts the number of rows in a table. Okay, so I just need to tell which table I want to analyze. And I want to analyze product. And I run it. Well, it turns an error, and it says the expression specified in query is not a valid table expression. As I said before, evaluate is trying to return a table. However, count rows is returning a scalar. So the two didn't match like they are now. A trick on here is using the encapsulated feature. With these two symbols here, we encapsulate the result, and we tell the evaluate to return the result in the format of a table. In fact, this is a table with one column and one row. Right? So this is a good trick. So if I want to know the number of rows in product, but also in customer, well, you tell me, just replicate your code. Yes, I could do that. Oops. I can replicate the code. I can do like that, and then do the same for customer. And if I run it together, the tool itself will show me the results, but into separators. It's like the result of the first query and on the second. But I want to see everything in the same query. For that, I can use one function that is row that will create me a row with multiple columns for the returning values that I want. So I can put a row. I can tell him to return me a product rows column with the count rows result, and then a customer rows column with the count rows from customer. And like that, oh, the syntax is incorrect. Why is incorrect? Rows. It's not rows, it's row. Okay. Like that, I have my result in a single display and in a single table. Okay. Another thing for you to have in mind. Let's continue and now use some different functions. Let's try to, to filter. I just skip it here one part, but I will come back later if I have the time. So let's filter one table. Let's filter by the product brand equals to Tailspin Toys. How can I do that? Well, I evaluate. I use the filter function that asks me a table, and I will say it's a table product, and then my filter expression. And my filter expression would be product brand equals to this. I will copy paste this brand. Okay, I just need to put here the comma, and then I have my original table, but filtered on the brands that are the Tailspin Toys. Okay, and then I can use this filter in the context of a calculate function. Remember when I said that a calculate is the most powerful function in DAX? Well, it is really, because it allows us to compute a measure modified by the context. I will explain what is that. So imagine that you want to calculate the total of sales amount. I know that we have here the sales amount on this table, sales amount. So I want to compute the total sales amount filtered in the context of the brand equals to Tailspin Toys. I can do that, and remember the calculate will return a scalar, so I use encapsulation trick, and I do a calculate. See the definition. It evaluates an expression in a context modified by filters. So the expression that I want to evaluate is my sales amount. And then I will apply the filter that I created. Okay. And when I run this, I can see my total. This is the value of sales amount when the product is modified by the context of brand equals to Tailspin Toys. This also works. This syntax is very similar, and in this case is the same as simply have here product brand. It's like a shortcut for the same thing, because the relationships between the tables are defined and they know that there is a path that can combine these two. So you will see that it's exactly the same. Okay, and you can even use this calculated expression to apply in the context of another on a table. So that is what frequently happens when you are designing your reports. So if you summarize the columns, I will use the product brand. And then let's put it together, the normal sales with sales amount, and then the sales, my sales, I will call it my sales, which would be this calculation that we just did before. Okay. When I run like that, I can see that I have the product brand. It's just like in Power BI. If I drag the product brand from a table visual, I have all the sales, and you see that for my sales, the context was changed and it's just calculating for the tailspin toys. So for each row, the context is simply the tailspin toys. Okay. So that's also something to have in mind. I keep going, and now an example for top N. Top N is something that, in my case, I needed it already many times in my reports. It's something that is very frequent to use. So I will tell you how it works. At open, it's simply this function. Returns you a given number of top rows according to the specified expression. So let's say that I want to top 10 rows of the table product. And now I need to define my order by expression. So I would say I want my top 10 products with a higher unit price. So the column that I define here is the product price, the unit price, sorry. And I say that is descending because I just said with the higher unit price. And when I evaluate that, I can see that I have my top 10 products. They are not sorted. The unit price, well, in this case, it's the same, but if I put 20, I think I will see different unit prices. Yes. And as you can see, it's not sorted, and you can sort the result after. So after I evaluate, you can apply an order by that will sort the result of the evaluate. So I will order by product unit price, in a descending order. Okay, it's descending right now. So that's how you can manipulate the results that you retrieve from your DAX query with evaluate, and then after you evaluate, you can apply an order by to manipulate the results. So now let's try another thing, all the combination of product brand and product category. What is that? In fact, this is a simple group by. This is a simple group by that we can do in DAX with the summarize function. It asks me for a table product again, and then the fields that I want to group by, which will be brand and category. And simply like that, we will have all the different combinations, and then you can apply here a measure as we did for the sales just above. Let's keep going and do what I just said, trying to apply an aggregation and then create a measure. So let's evaluate again. Now I will use summarize columns. The two are very similar, the way they work. So in this case, we can use one or another. Just the fact that summarize obliges us to first identify the table, and the summarize columns doesn't, so we can use here columns from different tables. So I want to summarize product category, and then I want to count rows. I want to know how many rows for each category I have in my table. So I create here an expression, number of rows with the function count rows of products. Let's evaluate, and here it is the result. The number of rows for each category that I have. Okay, so far so good. It's easier or not. Let's change here a bit the context. Instead of working with products, I will start using the customer. So let's first inspect what we have in the customer. And I can see that we have information about personal data about the customer, if it has children or not, the geographic information. So I will focus a bit on this column, the total children. And I want to know what is the maximum number of children that my customers have. So what do you think? It's simply a max. It's a max of one column, which is the customer total children. But remember, the max is also a function that returns a scalar. So I need to encapsulate this to be able to see the results. And it's 5. Okay, nice. So what about how many customers have a specific number of children? So an aggregation as we did before. Yes, I can also do that. I can use the summarize columns. I will summarize the customer total children column. Again, I will create a count column and use account rows. So you can do this for the table that you want, whenever you want, you do. So we can have here the result. I can see that it's not sorted, so let's put it sorted to better read total children. Okay, sort ascending. And here we have the result with a better format. Okay, so we can also create custom columns to add to our original tables. And that's what I will show you here. I want to create a custom column to show, like a flag, to show in my table if the user has children or not, just a flag. And I can do that, with evaluate and add columns function. This add columns asks me for a table, the name of the column that I want to create, and the expression that will calculate the column. So I want to add to the customer a flag has children, and the expression is if the customer total children is bigger than 0, it means that it has, otherwise it's false. And when I run this, I will see my initial customer table, and at the end, with my new column created as children. We could also have defined this column in a separated way, in a way that I can use in more than one formula. I can reuse every time that I want. And to that, I would need to use the define column syntax, which comes before the evaluate. So if I want to do that before the evaluate, I need to define a column. I will just copy paste the code. So I will define one column. In this case, I will call children2, just for you to see the difference, and exactly the same expression. And now, when I evaluate the customer, I will see my column created as children2. And now I can just refer to as children2 without the need of writing the expression every time I want to use this logic. For instance, now I can do an evaluate summarizing the customer customer table. The customer has children too. Now I can refer to it. It is not appearing, but it exists. And now I will do a count again. It's the simplest. Count rows from customer. Oh, sorry. From customer. And if I run this together, I will have two outputs. The first one is just the customer with the as children to created. And the second output is the output of the summarized. And you see, I just needed to define it once. Okay. And now, just two examples left. I want to show you that, well, we already speak about it, but we can summarize fields that came from different tables. So I can use state, and I can use product brand, and it will summarize me. And I can even create, let me show it along with the sales amount. And it will work. And why is it works? It's because we have the relationships defined between the tables in our model. So you can see here the result. And then just to end, I would like to show you also a define, as we did above, but with a measure. You can use a defined column, but you can also use a defined measure. So taking the example that we did with the calculate in the beginning, it's not the same example, but it's similar. I would want to summarize my date, fiscal year, and then I want the total sales amount. And imagine that I want in the same context the total sales amount of the previous year, just to start here with the time intelligence functions. And for me to do that, I need to use a calculate that, as we said before, changes the context of my calculation. So I want a calculate of sales amount modified by the same period last year function, where I need to give it the date. Oh, it's not working. Date. And another one. Yes. So when I run this, I can see my total sales, and I can see the total sales amount of the previous year. For 2008, I have the value here of 2007, and the same for the others. So this calculation is being modified by the same period last year. I could have defined this calculate also in a defined measure, which is what Power BI do when you create a measure and you use it in a visual. And to do that, I just needed to create something like this. Before the evaluate, you define a measure, not a column now. You say the name, my total, and now you apply this calculate. Okay, and now instead of using here the expression, you use here my total. And I have to run it everything together, and it's the same as you have. Okay, so it's pretty much this. I know this is some simple examples on what you can do with DAX. Of course, there are a lot of more things that I could show you, but there is no time. We could be here a week talking about DAX. So just to finish my presentation, some key notes at the end. Sometimes when you start doing some very complex things with DAX and it seems to be a complete mess, just stop and think. Sometimes it's not you, it's your data model. If your data model is in a good shape, if your data model is performative, your DAX formulas will also be. And another thing, if it's not format, it's not DAX. This can be applied to any language. So try to keep your code formatted. You see that your formulas can become very big in small steps. So if you format, it's easier for you to read. So this DAX formatter tool that you can search for it is very helpful for you to use to format your formulas. And thank you again. Thank you for your attention and for you to be here. So if you have any questions, you can pose them now, or you have also here my contacts and also the links for you to see the two dax.do files that I just present you. So thank you.
Thanks, Susana. We have a question on the chat. Do you have any certifications to DAX, or it's related to the Power BI?
Do I have, sorry?
Any certifications?
Okay,
related to DAX?
There are a few certifications that you can do from example, from Microsoft. It's not specific just DAX, but Power BI in general. For instance, the DA100 certification is for data analysts that use Power BI, and you have a bit of DAX, you have a bit of Power BI, a bit of visualization, and for sure it will help you on this DAX concept. I'm not sure if there is some certification that is just DAX. I'm not aware of that, but I can try to search and answer that. But you can also in Microsoft site, you have all the certifications available.
Perfect. Thanks again, Susana, for your time, for your presentation. Thanks everyone to joining us. I send on the chat the link to the next sessions. So thanks again and see you soon.
Thank you very much. Thank you all. Goodbye.